Good morning, everyone. I'm so glad to meet you here in this number. I hope this number will increase during this time. My name is Petar Šolić. I'm here co-organizing this with Mr. Patrono from University of Salento, and welcome for this Internet of Things, Industrial Internet of Things workshop, where companies will present their so far reaches in their own work in the field in the Internet of Things, and special thanks goes to this Croatian Science Foundation, which founded this project and which made this all possible. Just a short at the beginning, we are inviting you all for the opening ceremony, and after the opening ceremony there will be lunch served in the meantime, and then there will be Professor Marocco talk on very interesting topic nowadays, and you are all welcome to attend it and ask questions and everything else which you are interested in. And now I'll leave Mr. Patrono to give you another words about this workshop. Thank you.
Good morning and welcome to everyone in the third edition of the Industrial Internet of Things workshop. This event is a parallel event with the scientific event, and I think that it's very important because with this workshop is very important because offers the opportunity to know the industrial point of view on the Internet of Things here. This year we have 10 different companies involved in the workshop. The workshop are Central Inc., ST Electronics, Horizon Sense, Engineering, Polnet Italia, SpliTech, Ericsson, Amplifico, and the last is Sofix. So we can start with the presentation of the companies. We have a maximum 10 minutes for each presentation. The first presentation is CERMET. CERMET, the speaker is Federico Pitu.
Thank you.
So,
Okay.
it was working. Here, so here.
Yes.
No. That one.
No. But is a PDF or PowerPoint? PowerPoint. Okay. Please.
I think that 10 minutes are starting now. I will show you one of our solutions. The solution is about metal part tracking by RFID. My name is Veljko Bituh, and I come from company CERMET. CERMET is a solution provider in Croatia with a great experience in barcode industry and in last few years in RFID industry. So we are dealing with, of course, in our solutions with various equipment in RFID and also barcode industry. The project is for company Siemens. Everybody knows who the Siemens is. Siemens decided to go with new technologies like lean technology, Kanban technology. This part of the project is paperless production. So in the paperless production, they decided to track the goods from the entrance till the exit of the company with RFID. The specific thing is that it is about the metal. So Siemens has a lot of production facilities in the world. One of them is in Zagreb. It is company Končar Power Transformers. The Končar Power Transformers is producing big power transformers, which are metal, very complicated metal products with thousands of components. So there are sometimes very complicated and several hundred tons big products. So these are their products. When they decided to go with the RFID into the production, then we discussed how to start and so on, and we concluded that it is best to start with the pilot project. And we decided to cover all the production with the RFID. So you can see there are two ports where the goods are incoming. There are some portals where the goods are entering the production line. Then in production line we have some smart boxes and handheld terminals. And of course we have the forklifts which are taking the pallets. The goods are always on pallets. And the goods are stored in the yard of the factory, on the open space. We started the pilot project last year in June. And the pilot project was done with one portal, which was done by one impinge reader and four long-range circular polarized antennas. It was 4.5 meters wide, and we of course we used the computer. We used our software and the impinge software to compare the results. So these are these antennas on both sides of the port. On the pallet, right up the right picture up right is one of the cases when the goods are coming on the pallet. So we marked every part with the tag. In the pilot project we tested 10 different types of tags: HID, Omni ID, then tag factory, Xerify, magnet tag, but we had the best results with two tags. One is the HID inline for metal, and the other is Omni ID power tag, which is a dual radio tag. To track the pallets, we need a long-range reading. So we use this tag to have both possibilities, to record it on the entrance of the portal and to record it on the long range in the field. The tags are dedicated for the pallets. All the tags are in the closed loop application, so they are coming at the beginning to the producer and then finishing after the production. The results was astonishing. We have been expecting 98% of reading, but we have got 100% of reading. This is another scenario, so we made roughly almost 20 different scenarios with 20 different pallets and goods. So the second scenario was also with 100% of reading. They are also using tubes and various types of similar products, which are carrying on the cages and also passing through the portal. Also had a 100% of reading. The worst case was when we had several layers of metal, and when we had a situation where you have the tag inside covered by the metal from all other sides. And we also had the reading range of 100%. Our conclusion is that we chose the right tag and that we didn't have a wide portal. And the results have been very astonishing in this. All these scenarios have been repeated for 20 times. On the long range, we used the Omni ID development kit with a small antenna, and we have got the minimum distance reading 35 meters. We have got even 15 60 in some cases, but the minimum was 35 meters, which have been satisfying for us, and we decided to accept this solution for the long-range reading, especially because we will use in the project the real antennas, which will have much better results in the range. And this application will go for triangulation for the defining the location. We also used the handheld terminal, few handheld terminals to have possibility to pick a certain item from the group. So with the Geiger counting the strength of signal on the terminal, we can find the proper product between many. So these are pictures of the articles in the yard. Also we had 100% of reading in these 35 meters. So to conclude this pilot project, we concluded together with the customer that RFID technology can be applied for identification of metal parts in their case. We have been very satisfied with the results of the reading, and we suggested to the customer to go with the project. In meantime, the customer formed the group together with us, which have been producing the project, or we called it blueprint. In this document, I can show you later all this document. We defined everything. We defined the actors, the roles, the goals of the project, the KPIs, the business processes, defined all the schemas. We defined the equipment for the whole factory. We defined it also the communication, changing the data between ERP, which is SAP. We defined also the terms for implementation. The project started 2 weeks ago, and we are expecting that we will finish in middle of September with this project. The budget for the project is 250,000 euros. These are samples of the ports on the left side. This is one of the ports, and there will be on both sides the same specification. The middle picture is entering to the production, so we will have 5 of such ports. Then there is a specific product which we developed. This is the smart box. This smart box is dedicated to gather all the tags at the end of the production, because every tag have to be checked that it belongs to the working sheet of this proper power transformer, because you can have the similar products on 2 power transformers, but it is not the same because of the lot number of the product, where to go. So we can, on this computer, there is our application in the background, which is checking if the tag is, if the product is proper for this working sheet. So there is no mistake in delivery. For the questions, I will be out there, and you can ask everything you want. Thank you.
Thank you. The company is Sensor ID, Italian company. The speaker is Alfredo Salvatore.
8 minuti di avviso quando manca uno, perché il messaggio è lungo. Good morning, everyone. I'm Alfredo Salvatore. I'm the CEO of Sensor ID. We are a company located in Italy, and basically we are a producer of hardware device based on wireless technology for IoT application, and specifically we are focused on RFID technology. This is the company organization. We have inside our lab either the capability of R&D and development of hardware and firmware, either the production of the device that we design. we have also the availability of some equipments for the realization physically of the devices. This is just an overview of the products we have in our portfolio, and this is some of the collaboration we have with R&D entities and with silicon factories. Which is our vision? Our vision is to make clear the difference between the Internet of Things and Internet of People. Normally, the Internet, in the world of the Internet of People, so consumer devices, people are looking for devices that have great performances, a lot of functionalities available, the possibility to install a lot of applications, for example, on the smartphone, laptop, tablet, and so on. In the Internet of Things, we have the opposite of the scenario. We have the constraint to realize devices and applications in a very precise way, dedicated to do just one thing and do this thing best, at the best. Normally, the user of IoT devices don't choose the device, but the choice of this device is up to their manager. So the device has to be very simple to use and dedicated precisely to the application. In this way, we developed a complete solution for the waste management based on a wearable device directly connected to a cloud platform in order to collect the information by the operator that going around collect the bins and have the needings to identify the bins they are collecting. In this way, we realized, despite to the market that propose complex infrastructure to be installed on the vehicles, we propose just a very simple wearable devices that can be wear by the operators. Another application we developed in this way is a token, a wearable token that we realized for Lamborghini and hopefully they want to extend also to Audi Group. And the purpose of this project is to integrate inside the wearable devices all the functionalities of the company smart card. So PKI authentication, digital signature, access to SAP services, access to automatic access to the company portal. And what they have to do is to guarantee the compliance with all the software already installed and with all the mobile terminal based on iOS. This is the project in which I want to focus this morning. This is a project we realized with Luxottica. Maybe you know Luxottica is the most important producer of glasses, and the goal is to track and monitor the production process. Luxottica has an identification of the batches based on a sheet of paper. So the goal was to apply to the sheet of paper a RFID label in order to monitor all the production batches during the process and load all the information on SAP. This is, you can see, one of two examples of applying of the tag on the batches. As you can see, the scenario is a bit complex because the glasses has a lot of metal, so we had to choose the right label in order to avoid and minimize the probability to shield the tag reading by the glasses. The project was based on this architecture. So basically, we developed a middleware. We installed a lot of antenna around the plant, we install either antenna for gate, either antenna for buffer. So imagine that in a certain area you have a lot of antenna installed on the top in order to verify the presence of the tag below the antenna. In this way, we had to develop also a mechanism to avoid the interference between antenna and others. Because consider that in one area we can have more than 20 antennas installed. We developed the middleware inside the antenna. So we avoid to develop software out of the antenna, and the antenna is fully integrated with the SAIP. And also we developed an interface for monitoring and debugging of the antenna. So we developed a sort of control board on which remotely it's possible to monitor and configure the antenna in order to verify the channel frequency on they are working, if there is some problem in connecting to the SAP agent. So the goal was to realize an infrastructure that can be fully maintained remotely, because Luxottica has no resource to allocate in IT area to maintain the infrastructure. We realized the pilot project from November to April of this year, and the result was so good. We obtained a reliability more than 97% of readings during all the path of the plant, and Luxottica decided to extend this system to all the plants they have in Italy. So they have in Italy eight plants. This is just a look of the interface of the management platform we developed. This is another application we have in our portfolio. Basically, it's an integrated access control system that is fully loaded inside the RFID antenna gate. So if you want to install an access control system, for example, for vehicular application, you don't need to install other hardware, but just the antenna, because all the software, all the application is running on a web interface loaded inside the antenna. This is another project we developed by the end of 2017, and this is an R&D project we developed with Technogym. Maybe you know Technogym is maybe the most important producer of wellness and fitness equipments, and based on in this case the goal was to realize a component of the machine. So the goal is to realize an RF sensor that is able to measure precisely the power you are generating when you do the exercise on the equipment. We arrived to the patent with the Technogym at the beginning of we got the patent at the beginning of this year, and this went in production in December. So now is in production this solution together with the Jebil, that is the manufacturer of the board, because we have not in our company we have not the infrastructure to realize so many pieces, because consider that this equipment is realizing more than 20 key pieces per year, so it's a huge amount of production. Okay, thank you.
Thank you very much. Next presentation is ST Electronics, a big company
that works on chip and on Internet of Things. Possiamo usare questa qua se vuoi. Sì. The speaker is Antonio Vilei.
No, faccio col mio, mi dispiace, faccio col mio.
Oh, okay. Can you the full screen?
To go full screen. Oh, this is a PDF.
Ah, this Croatian.
Yeah,
Okay.
yeah, so it wasn't easy.
Okay.
Okay.
So, not. It's going on.
Okay.
Perfect. So, hello, my name is Antonio Vilei. I work for ST Microelectronics in Italy. ST Microelectronics, just let me show you, is a multinational company. It's the main company in Europe for microelectronics. Last year it had a revenue of around more than $8 billion, and it has over 40,000 employees worldwide. And for each dot you see here on the map, there is one site. And a lot of people in ST work in research and development. And ST is also very active, and this is the purpose of today, showing you a solution that we have for building Internet of Things prototypes. So if you want to have a prototype for Internet of Things application, we provide you with a system which is a bit like the Lego that you see here. The Lego bricks that you just put one on top of the other and then started with simple blocks, you can build something more complex. And here the idea is similar to the Arduino concept, only the difference is here we provided a 32-bit microcontroller with professional software and environment and help you all the way to go from the prototyping to the production. So just to give you an idea, so Internet of Things devices come in many form factors. You can see here a lot of devices. They can go from wearable devices like bracelets that you use for fitness. They can be toys like this, or they can be drones, robot like this. This is another toy. You can use it for sports application. For instance, in the ball, you could put sensors to understand how you throw in a ball and so on. There could be a toothbrush, for instance, that can help you check if you're brushing your teeth properly. It can be a smart meter for electricity or gas. It can be a washing machine. It can be a smart door lock. So it can be whatever you want. So there are many different things. But if you go and look inside these devices, you'll find that even if they look so different, after all, their needs are almost the same. And this is where ST comes into the play. Because you need, independently if you're targeting smart things, or if you're targeting smart home and city or smart industry, you will need processing power. You will need something to run your application, the brain of your system, where the logic can run. And ST can go from very low power microprocessors that have to be powered by batteries to very large and more high performance processors. You need security because whatever you're doing, if you're doing smart home, you don't want people to enter your house because you have a smart door lock that people can easily break into. If you have a smart grid, you need security because you don't want that the smart meter, when you're dealing with the price you have to pay, somebody will try to cheat and pay less. You need sensors, because they are like the senses of a person, like needs a brain, which is the microcontroller, needs the sensors so to see what's around, and then you need actuation, like motor control, or whatever. Then you need connectivity. Of course, we're talking about the Internet of Things. So without connectivity, you would have the things without the Internet. And you can have connectivity which goes from very small range, like 10 centimeters, to kilometers. So it depends on the kind of application you're targeting. And you need also to deal with signals. You have to work with signals and condition the signals. You can work on signals that are just nanoamps to signals that are kiloamps in an industrial environment. Here, of course, motor control. You can have motor control for many kind of applications. They could be the motor inside an elevator. It could be an industrial machine. It could be a small robot. It could be a small toy. So there are many different, it could be a car. And then you need power and energy management. So ST has a very complete portfolio in this regard, because ST has microcontrollers, sensors and actuators, connectivity, energy management, analog products, secure solution, and motor drivers. So, for instance, I don't know if any of you is familiar with this development board by ST. It's called the STM32 Nucleo, and it's based on the STM32 microcontroller, which is a 32-bit microcontroller based on the ARM Cortex-M architecture. So, has any one of you ever seen this? Okay. Yeah, of course. So, and here you can have the microcontroller going from the very low power to more powerful and so on. But it's similar to the, here you can see also there are the Arduino connectors. Because ST also provides for each of the components that I've shown you earlier in each of the categories, like sensing or connectivity or motor control and so on, ST provides you with expansion boards, which are like the Arduino shields. The difference is that all these boards that you see here, it's a very wide array of boards, are all based on ST chips. And you find all the software environment which is provided by ST in a unique and unified environment where your software will run, and you're supposed to be able to use it both for prototyping like you would do with Arduino. But then from the prototype you can go into production. And I show you now how we want to simplify this industrialization journey of your product from prototype to the shelf where users can buy it. So first of all, you have to start with your idea. Then right now you can buy already the microcontroller boards, like the one that I've shown you earlier, and the expansions to have the functionalities you need. Then by plugging these components one on top of the other, you can have your prototype in just a few weeks. Then after you refine your idea, your software is ready and you debugged it and you know it's working, you can go from a board which is very bulky. By the way, later there will be a demonstration session, so I will show you the boards on one of the desks, so you'll be able to see them. Now, since the time is short, I will be just quick. But you can go from boards that are quite bulky to very small form factor boards that you can use to test your idea on the field. And then, after you have this, you can go to the market with your complete solution. So we provide you also some partners that will help you with if you want to, with the PCB designing or using some form factor boards. What we do, we provide you all the blocks. What we don't give you is the idea. So it must come from you. And just to show you how from bulky boards that are as big as the Arduino ones and the shields, you can go to something smaller. Here there's this idea, because this is shrunk into a small board which is 1 centimeter square. So this is very small, so it's not up to scale, because this is much bigger. The left hand side is much bigger than the right hand side. That's the board that you see there on the right is just 1 centimeter square. And with that one, you find exactly all the things you have here, like a microcontroller. You have some accelerometers and gyroscopes based on MEMS technology, humidity and temperature and pressure sensor. Then you have Bluetooth low energy for establishing connections with the mobile phone. And then there are also some MEMS microphones, all in this very small form factor board. So just to conclude, ST solution for the Internet of Things also comes with some readily available software solution where the typical combinations of functionalities that you would need in real life projects are already pre-assembled so that you can start from that. And we provide also support for connection to the cloud, and we support 3 of the main major providers in the cloud with the SDK already pre-integrated so that you can connect to the cloud in minutes. I have a demo later where I have a board where I can send in real time data that you get from sensors on board by using Wi-Fi to the cloud, and then you can connect with your phone to see the data in real time. Then we have, as I said, 131 software packages that go from drivers to full application examples, as I was mentioning. And we have 27 Nucleo development boards where you can find many different kinds of microcontrollers. Based on your needs, you can have the low power ones, the high performance ones with more peripherals, less peripheral, more flash, less flash. And then you have 38 expansion boards that provide you with the components that I've shown you earlier to expand the functionality and build your prototype. And then from that, we also have a number of boards provided both by ST and by partners of ST, which are very small and will help you, like I've shown earlier, from the bulky boards to the little one, will help you try the same software, exactly the same software. You don't need to change anything. It will run straight on these small form factor boards that you can try on the field. And that's it. So I've been very quick. I tried to. I don't know. Was there any minutes left? Otherwise, if there are, okay. So if you have any questions, meet me later.
After the presentation session, we start the exhibition area. We can continue to ask another details directly to the program. So now we have the Italian startup company, the Sense. The speaker is Sara Mendola.
So, good morning everybody. I'm Sara Mendola. I'm a co-founder of RadioSense. RadioSense is a spin-off of the University of Roma Tor Vergata, where we are currently settled, and was founded in 2013, so 5 years ago, more or less. And is today composed of a team. We were mostly ex-students of the Pervasive Electromagnetic Lab of the same university. Professor Gaetano Marocco is the president, and there are some people with the PhD. So, as I told you, we all come from the Pervasive Electromagnetic Lab, so we have an academic background. So at a certain point, we decide to bring to the market the product of the research that we believe that were mature enough to be transformed from a simple laboratory prototype to real industrial product. So we are somehow the front end of academic research toward the market. We bring the product that are more mature to the market, but then when we go to the market, we also bring new challenges from the market, from the real world, from real application, and we bring back these challenges to researchers that are still working on more challenging scientific topic. So this mechanism somehow generates a very virtuous cycle. So bringing research to the market and then bringing challenge from the market back to the university. So we have been working on RFID technology, that is our main focus for more than 15 years in academic scenario. So here you have just an overview. We have published and we still keep publishing many papers on international journal. We receive a lot of prize and award in international conferences. And what is every company has a mission? Our mission is basically to transform, to move from the wired sensing infrastructure in industrial scenario to a new wireless sensor infrastructure that permit to make complex measurement in industrial scenario much easier because we can distribute a lot of sensor in the space. We do not have to spend time, to waste time to put heavy cables. But no, I would add something. Not only we want to make wired standard measurement more simple by exploiting the wireless technology, but we want to enable also new way to make measurement, because there are sometimes some application where you cannot use standard application. And when I mention standard application, I'm thinking on wired sensor, but also, let's say, more widespread battery assisted sensor. Even when they are wireless, they usually need a power source on board. So you can think that sometimes you need to monitor very complex machineries where you have a rotating part, or you want to monitor some parameter in an industrial process inside an object that is very hot, so you cannot put a battery on site. So we want to exploit the RFID technology to make this kind of very, very harsh and complex type of measurement. So our expertise is mainly based on an electromagnetic background, on antenna design, RF communication, but since our focus is on very harsh, unconventional, high demanding scenario, it is extremely necessary to merge different expertise. So since we are settled inside the university, it's very easy to combine different background, so we are able to face all the aspects of complex problem that start from the characterization of the materials to the mechanics, because sometimes the sensor must be integrated into the material, so we have to combine different expertise up to the upper level, so going from the physics of the object that we want to monitor up to the cybersecurity, so the protection of the data that we are gathering from the thing that we want to monitor, up to the data analytics. So we can define ourselves as a good partner, an R&D partner for making open innovation inside for external company. So as I told you, we usually work on very unconventional applications. So we are always asked to make some technological development or about something new, because when customer ask us to solve a problem, they couldn't find any solution on the market. So most of the projects that we developed are based on a very customized solution that many times requires an ad hoc design of the radio sensor. And we also provide some training services, and this is very nice because we have started organizing inside the company, sometimes even before the starting of a real founded project, some training sessions that are not only, probably have some picture here, you can see some training session that we organize also inside a very big company that involve different people inside the company, not only engineer but also people that are on a working line. And this is very important because once our customer become conscious about what they can do with our technology, they know better than us which is the process that we want to monitor, so they become somehow proactive, and we can interact in a very virtuous way to set up a new innovative project. So we usually follow the project from the physical layer, so from the data generation with the development of ad hoc wireless sensors that are mostly based on UHF RFID technology, but not limited to this technology. Depending on the application, we can also consider different protocol. And we usually go from the design up to the prototyping. We are able to set up a pilot demonstrator on site, on the premises of our customer, and then we help the customer, we support him or other external partner for the industrialization of the product. Then we also, in the project, we take care of the different protocol for the data transmission up to the data analytics. Here you have some facility that we have in lab. We are able to make simulation, some rapid prototyping and testing of our product. We do not have a catalog, since our applications are very uncommon, so we have a kind of portfolio with some building block prototype that help us to set up a very rapid demo to start the development of new devices. We work both on the radio sensor side, but also on the reader software. We are able to interface the reader with typical standard protocol communication for industrial settings. These are more or less the field of application, from automotive to monitoring infrastructure, building, and also health. And if you go to our website, you will find a list of our main success story. If I have probably 1 minute more, I can show you a couple of applications, but you can come to visit us at the booth and we can discuss more. So just to give an idea of which I mean for a complex industrial process that we can monitor with our solution. This is an example of an interesting project we developed for an Italian manufacturer of conveyor belt, that is this rubber-based product. The customer needs to monitor the temperature inside the rubber, and he needs this information to control its industrial process. So we develop custom tag to be put inside the rubber. We interface the reader with the PLC of the pressing machine that perform the vulcanization during the curing profile. So we give him a way to control its manufacturing process, to certify the quality of the product in a very precise way. And then the second and the last application give you the idea of how we can use many sensors distributed to make complex and heterogeneous network to monitor critical infrastructure. In this case, we deploy an RFID network inside an electrical cable that was settled on Favignana Island in Italy, but this idea can be transferred to whatever critical infrastructure you have in mind, from power plant to nuclear plant. You can imagine that you can deploy different reader antenna, heterogeneous sensor, very simple sensor that give you, even without any battery on board, without any dedicated sensor on board, just processing the level of the signals that are transmitted from this sensor. You can combine all this information to retrieve with some processing very complex information. In this case, we process this information. This is an example of the dashboard that collects all the signal to retrieve high-level information about a critical situation. For example, we were able to understand if someone tried to access the cabin if it was not authorized to do it, if there was some anomalous behavior in the machineries, if there is a type of a cyber attack to the cabin. So this technology in this particular project was combined with more standard video surveillance, audio analysis to make a very high level of security of critical infrastructure.
Thank you very much.
Then we have a list of other nice applications. So yeah, sure.
Thank you. Next company is engineering. Another big company focused on the Internet of Things, high level software and cloud services and other similar things. The speaker is Stefano Pino.
Tutto saturo? C'è già un mouse? Vabbè.
Ah, ok, posso usare quello.
Vai.
Okay. Hi, I'm Stefano Pino. I work in engineering informatica. I will talk about I will give you some information about engineering, but not just engineering. I will talk about my group, my team, which is OPSI, Open Public Innovation, Open Public Service Innovation. So then I will try to give you a wide spectrum of what we do every day, and I will talk about our experiments, and then I will talk about other experiments. What I'm going to say it will be very will be a very small part of what we really do. So there will be more information for you if you talk with me later. However, what about engineering? Engineering is a big company, Italian company. It is IT consulting company working in all around the world. We are about more than 88,000 professionals in 7, maybe now 8 countries all around the world. We work at business integrators, consultants. We provide products and solutions. The phrase is still in Italian. However, I will talk about us. We are Open Public Service Innovation. Engineering it works as in consulting, but there is a small branch which works in research, and a smaller part works with public administrations and services for citizens in order to enhance the relationship between public administrations and citizens, of course working in various towards various assets like smart city and smart community. Both assets will deal with different research topics, which are public sector innovation, public government, open service innovation, public governance, and so on, open data, big data, social innovation. The idea is how technology could enhance the everyday life of citizens and create a virtuous relationship between technology
and sustainable between technology and the city itself. So we have other topics like privacy management, data-centric city platforms, and so on. And all the topics I am presenting are developed for the creation of the resilient community, which is the heart of the smart city we have in mind. Our services for IoT, our services for the city manager and citizens have to be resilient. What we do every day, we deploy services. We work with virtualization at several degrees. We work with virtual machine, Dockerization, orchestration, and we are working with, as software architects, we are designing microservice architectures. As I said before, we are working for the resilient city and community, and this is a resilient software architecture. This is the backbone for IoT services, and enabling layer for us is the Fireware project. Fireware project is a project we have contributed in the development and creation. It's a full stack of services and application for the management and deployment and the fruition of the IoT services, which gives you a standard layer of interaction between the users and the IoT system, which, as you already know, the IoT devices are scattered around the world or are very different, and you have a full stack of applications available for you in a catalog where you can choose and deploy your generic enabler, which may help you at different levels. What we do every day is let them talk. We have the context producer, the context provider, context consumer, and what we call the context broker. Different entities which may be human or devices, which, let's see. This is the general structure of the Fireware deployment. This is structure 1, just to make you see how the structure works. We work at different levels. So we work at IoT edge, providing IoT agents in order to assess data in the IoT edge and move that data towards IoT backend and the cloud layer. So we work on all these three stages, and we provide not only the software architecture, but if you have prototypes and you miss some devices or some softwares, we are proficient in finding what's missing in order to complete the architecture. This is what we do every day. We work not just software architects or makers in order to build the IoT architectures, but we work as designers of newer, novel software, novel in ways of interactions. We have created this metaphor, which we call ubiquitum service, which is the mixture of the idea of ubiquitous and the idea of continuum. So the services and the prototypes I am going to present you are built upon the idea of ubiquitous and continuum service. What is continuum? Is a service which is continuum, consistent, and complementary, which lives between devices and not just within a specific device. It is a service which can move and adapt between devices. So I will present this later. This is the decentralized identity profile, which we use as a personal data store. I have a talk in the afternoon, but in general, it is an experimentation working with blockchain and a distributed file system in order to assess and manage personal data. Another prototype I'm going to present is the Tactus, the tangible composition tool for ubiquitous services, and it is a prototype which can combine IoT device in order to let them interact at any scale of interaction, which it is scalable, very scalable. Another prototype, which we call Immersity, for citizen-city interaction at different degrees through the virtual, through 3D models and virtual environments. Other experimentations, I will give you a list. We are working in advanced services for the city manager, as you can imagine, advanced IoT dashboarding for the city manager, GDPR applications, because the decentralized is only a small experimentation dealing with privacy of data, but we have other experimentations. We are working with the idea management platform, which may be connected to IoT. As you can imagine, you can plug devices within idea management platform in order to make citizens talk and decide how IoT devices may be used or may be useful for them in the city. We, of course, work with create and work with participatory platforms, and much more, which we work with machine learning and deep learning and sentiment analysis, and so on. We have many experimentations going on. I'm interested in gamified approaches and gamification.
Okay, thank you. Next company is Italia, another Italian company. The speakers are Alice Mazzini and Claudio Spirito.
I'm removing the.
Sul desktop, sul desktop. No. Quale nome hai dato? Presentation Wallet. Ci dai su una chiavetta? Sì, mettiamo una chiavetta, facciamo prima. Ok.
Là. Dai.
We are already at the last slide, so I'm finished.
Good morning to everybody. I am Claudio Spirito. I'm the manager of the IoT department inside Allnet Italia. Allnet Italia is a company, is a distributor based in Italy. The revenue in 2017 was 60 million euros, and we have a database of more than 5,000 companies. So I'm here for discussing about the role of the distributor inside the IoT value chain. So you can see the typical chain of the IoT market. The central ring is the distributor, Allnet Italia. On the left side there are the vendors. On the right side there are the system integrators. So let's speak about the system integrators now. Normally we used to deal with small medium business in the ICT field, and we see now that much more system integrators are trying to invest their resources on the Internet of Things field. But at this stage there are still many problems, many challenges to face in order to be competitive on the market. Normally the system integrator needs to understand what are the end users' needs. Then they have to tailor the architecture around the needs of the end user. Normally the process is to understand what are the best products to build the architecture. Then they have to build every chain, every part of the architecture. They have to understand what are the best protocols, what are the best boards, the best gateways. Probably they have to build their own platform. So the process is very long. Then to have to acquire data, and they have to validate the data that they have acquired, and the algorithm they used in order to provide complex information. So, as I said before, the process is too long. In fact, the system integrators who now are busy in the IoT fields are normally IoT core business based. It means that many system integrators still want to invest in the IoT, but they don't know how to do, because the road is still long before get to the market. On the other side there are the vendors. Also the vendors have got many problems, both on the commercial and technical side. On the commercial side, I would say, what's the business model for IoT? It's still not known as far as I'm concerned. Or another question is, the new need of business models are shaping the research on the IoT. Now we see that the model where the company buy resell devices is not work anymore. It's better to have services because there are subscription, so you can gain fidelity of the customer along the years. And this is got more advantages for the business. It's more consistent. On the other side, the technical specs still show some issues. For example, we don't see that still there's no convergence for protocols, middlewares, and architecture. For example, let's talk about sensors. Everybody knows that sensors must consume low energy, and they have to provide long distance communication. But what's the best protocol among LoRaWAN, Sigfox, or narrowband IoT? Nobody knows still. So in this case the vendors has to ask the question, is it better to try to lead the market, or it's better to wait that the market is stable and then try to add its proper value in an already existing market? So in this big confusion, what's the role of the distributor? I think that IoT is a fusion of different skills that comes from different fields. And data, complex data, comes from very different kind of information that come from different domains. So IoT is a new subject to study that comes from different subjects and different skills. So the role of the distributors nowadays is to continuously update the knowledge of the state of art, provide solutions that are ready to be used by system integrators, and try to build a business model that is profitable for the customers. So, as I said before, the model where you have to buy a device and sell it is not work anymore. New business models are needed because IoT means to optimize the processes and the resources that already exist in order to build a computer as to answer to the simplest but also the hardest question: what's IoT nowadays? And who are the most important players? They are simple questions, but still they need to be answered. Now we see only some of the brands that we used to distribute. This is Libelium, it's a Spanish company. They provide sensors. What's the main aspect of this brand? They produce boards to connect sensors, but also enclosures where you can connect easily sensor probes. Then you have to program them with a programming language that is very similar to Arduino, so very easy. They provide the API to program. In the center of the chain there's the gateway that allows to use very different protocols. So if you want to use LoRaWAN, you can use it. If you want to use Sigfox, you can use it. It depends of the application. Also because we think that there's not a winner in the application. So some application needs LoRaWAN, other ones needs LoRaWAN, and Libelium provide all the devices in order to build the most suitable architecture for the application. Then the gateway provides also cloud connection. So if you don't have your own platform, you can employ your third-party platform in order to have immediately the data to elaborate and to provide more complex information in order to get the automations easier. This is another way to face the problem. 1 minute. This is Monit. Also Monit talks about sensors. They've got a proprietary protocol and a proprietary platform. So if a system integrator wants to immediately use wireless sensors with less than 150 euros, immediately has got their own sensors and they surely work. So it means that they can use elaborate data immediately after I plug the sensors. At last but not least, there is Impinj. Everybody knows Impinj. We are the distributor in Italy. This is their typical architecture. The readers and the antennas, the gateways. The gateway also provide the localization of the RFID tag and the direction of movement. On the top side, there is the operative system that manages the devices and provide immediately the data from the RFID. That means that a system integrator works immediately on data without testing so much the devices. So we are just outside. Feel free to come to us, me and Alicia, to talk and to see the devices that I have just explained. Thank you very much for the attention.
Next company is Pizza. The speaker is Gianfeld.
We just check the speakers. They are. working, yeah. Okay. I hope so, because we have a short video inside the presentation.
Hello to everyone. My name is Ivan Perić and I'm an employee of Špica Sustavi. Špica Sustavi is part of Špica Group. Špica Group is located in 7 countries in the region plus UK. We are founded in 1989, so we are working on our products almost more than 30 years now. Our team consists out of 120 employees, and most of them are highly educated. Company is certificated with international certificates for quality and information security. Our products are based on cloud, mobile, and Internet of Things, and we are proud to say that we develop everything using software and hardware parts for our products. Our references are that every day more than 600,000 users use our products. We have more than 3,000 systems installed, and we have new projects every day. Our softwares are available in 15 languages, and we installed our systems in 27 countries so far. These are some of our references, and also the faculty we are here today is also one of our references, where we implemented RFID readers for students' presence and professors' presence on class, and access control to the classrooms. Other references here are from region. The biggest ones are Shipyard Split, Cemex Croatia, and I don't know, Airport Split, and etc. This is also one of our references. It's Tornado Tower located in Doha, Qatar. So there we implemented 160 access points with more than 100 controllers. Our core business was always time and attendance and access control. Our software is called Time and Space, where we develop our own application for mobile clocking, our own controllers for access control called Zone Wing and Zone Door, and our own terminals for clockings. Since this is Internet of Things workshop, we will present a little bit about our Door Cloud access control solutions, and also we have cloud time management called All Hours, which is meant for use of big companies, and cloud solution My Hours, which is used for personal time tracking. Door Cloud is actually our newest product. It's launched really in previous few months, and it's based on our own controllers. It's hosted on Microsoft Azure or Amazon servers, and it has support for HID and Apereo locks and readers. We are proud that we have OSDP level 1 protocol, which is really, everyone who works with access control knows that the readers are connected with wires to the controller, so you need to do something to secure the reader connection with controllers. So our OSDP protocol is something we use for that. We are currently looking for regional distributors of this product, and since we are really short on time, we prepared a short video to show you how the Door Cloud actually works.
Most access control systems today are used with RFID tags or cards. Yet, thanks to NFC and Bluetooth, we can now use our smartphone instead. Nice! Door Cloud is the first access control system, going one step further. Thanks to clever use of smartphone location, we can do access control without readers. Based on the user's location, Door Cloud's smartphone app will open only the doors which are close by. If there are several doors in close proximity, the app will offer the list of the nearest doors so that the user can select the right one. Thanks to a combination of GPS, Wi-Fi and Bluetooth, modern smartphones offer surprisingly precise location, even indoors. Readerless and reader access can be freely combined throughout the system. Apereo wireless locks are also supported. Door Cloud elevates the security, convenience and cooperation for all parties involved to a new unprecedented level. It is operated and offered to end users exclusively by local partners. Get on board and become a Door Cloud partner.
Okay, so how it's done actually? The traditional way of access control consists of a reader, controller, and server. The reader is wired directly to the controller, and when someone tries to access some access point, the reader sends information to controller, then controller searches its own memory and checks if the user that is trying to access can or have access right to enter that area, and or the other way it was the controller sends queries to the server and checks on the server if there are any access right for that user. So using the Door Cloud, we have another way of authentication of user directly from mobile phone to server, and the door, once the server user is authenticated, the door is opened the usual way via controller. So these are our controllers, our own product, Zone Wing and Zone Door that work together, and Zone Spot, our newest product that is actually Zone Wing and Zone Door together in one box. So both of Wing and Spot are Ethernet controllers. They are connected to the internet using Ethernet connections or Wi-Fi modules. Identification. To make access control work, you need to identify and locate the user. So using the readers and the cards. If you have the card, you know by the card that is presented on the reader which user is attempting to access some point. If you have the reader, you know where the reader is placed and you know which area is trying to be opened. So if you use the Door Cloud, identification can be made using smartphone. So everyone has its own smartphone. There is no need for buy of new hardware. And every smartphone has its own IMEI code, and it's personal. So every user has its own smartphone. Location is really evolving fast in smartphone. So the precision is increasing and energy consumption is improving. Really it works indoor better than outdoors, so it's tested on several sites, so we can prove that. But if you have any issues with location, you can easily enhance it by using Bluetooth beacons or NFC tags. The readers. So if you use the Door Cloud, you don't have to use only readerless access. You can combine readers and readerless access. You will use readers where you have high fluctuation or high passing of people through the day, and the readerless access on the places you have a really lower fluctuation of people. You can join us at our stand and we can answer all the questions you have. Thank you.
Next company is a big company, Ericsson. The speaker is Zoran Ivalic.
Sorry, just a second.
So hello everybody, my name is Zoran Ivalic. I work for Ericsson Nikola Tesla, Croatian Ericsson Cradle Problem Solution, and how the project is done here locally in Split. The basic problem everywhere, most of the cities, is parking. So this was the first tangible situation that can be used to really present and introduce IoT technologies besides of the industry and stuff like that. What are the problems? Global problem is, I presume most of you are drivers. Wherever you go in the big cities, you need a parking. Split is a specific situation. It is a really old town, city center, and even surroundings are built as they are. Like 50 years, 100 years ago, nobody had an idea about this number of the cars that would be driving around, people driving, trying to find the parking. So if you take it globally, we did a research, there is millions, literally millions of parking availability requests each minute done. 30% of the urban traffic, especially in the closed city centers, is actually searching for the available parking bay. It does increase driving time, it does increase the nervous drivers, slow traffic, traffic jams. One of the most important things in later years is ecological situation. So it's loss of CO2 emissions, and of course, people don't know where they're driving. I come to some new city, I have signs here and there, maybe I can find something on the map, but basically I have no idea where I'm going, so most of the really huge parking bays are not utilized. So that was a problem. I'll try to make it brief so we can make it on time, so I hope you all understand the problem. The solution is to build independent system that can provide you with all the information you need to navigate you to the driving spot and giving you the possibility to pay directly from your mobile application. So we designed a solution that gives you the information about parking bays, occupancy, with all the details about the specific parking bay, location, availability, prices, rates, working hours, whatever you need to know. Of course, you can browse through the parking bays, you can find it on a map, you can even tap on your application and try to say, okay, I'm going here, give me the nearest available parking lot and navigate me through there. So the physical system is rather simple. We have parking sensors. All the communication is wireless, goes through the relay nodes, the gateways, to central system, and then information media. Sensors itself, I will show you later on some photos, they are basically built into every parking bay. We drill the hole, put the sensor in there, and that's it. They're all, we chose as a partner for technology, we chose the Dutch company called Nedap. They have really reliable equipment. Every sensor is like one closed, it cannot be dismantled, batteries inside, it's like a monolithic piece of equipment. The life expectancy of the battery is 5 to 10 years, depending on the usage. These relay nodes are also, you can see them around, if you walk around the Split, you can see them on the street lights, and the range is about 35 to 50 meters of each of them, and per each location there is one single gateway that is powered by the solar energy. The information goes through the 2G, 3G, 4G to the central system, and then we go down and present it on the smartphone application. Basic components are sensors, software system like the backend, mobile application, and the communication network, which is completely wireless. One of the biggest benefits here compared to some other systems is that we didn't need to dig anything for the cables. It's just built in the sensor, and everything is wireless. You mount the relay nodes and gateways on mostly on the traffic lights. We had some in entire city. There is only one relay node that is actually built on the wall of a house. It's mounted on the wall. We tried to. That was one of the biggest challenges here, was to try and organize equipment deployment based on what you have in field, like traffic lights, traffic signs, street lights, even parking machines. Whatever we found, we used for it. Some of you will say, okay, there is now narrowband IoT technologies, new technologies, you don't need the relay nodes, gateways, and all that equipment. Yes, that's true, but this is happening now. We needed the technology now. We deploy the sensors, physical components are here. We have the backend system in, say, 2, 3, 5 years when narrowband IoT technology will be here, actually available everywhere. Because we are still, some of the countries have it deployed, some more, some less, but in Croatia we are still working on it. Hopefully next 2 years, they promise we will have more than 80% of the country covered with 5G, so I hope then we will be ready to introduce some other technologies. The system is here, we can use any technologies besides this sensor that we're using now. That's the reason why on this solution overview I didn't want to show physical components, because it can be interchangeable. We have this technology today, tomorrow we can have some other technology. So basically it consists of the central system. Just to give you the brief overview how it is organized. We have, since you can use mobile application to pay for the parking, we have to be connected to payment gateway, to the mobile operator as well, because you can pay via SMS, so the money is deducted from your prepaid or postpaid account. Of course, parking enforcement company for issuing the daily tickets, all the legal stuff that is concerned with the parking. That's in Croatia is RAO, the company is called. On the other hand, we have mobile users, IoT and Android mobile phones, a system administration for the entire system, and the parking operator statistics and reporting. This system can be used as a multi-tenant. Currently it's used for split parking only, but it can be used for multiple parking operators in the same city, in different cities, whatever. There are various solution benefits. As I said, I'll try to make it brief. I will be around here, so later anything you need to ask, you can ask me. For the end users, as I already described, mostly you have the information, you can navigate to the free parking spot, you don't have to spend time searching around, and you can pay from your application. For service provider as a parking owner, benefits are you get a huge amount of data for the analytics to increase the utilization of the parking spots for better management of your parking lots. Of course, you can connect this to any other analytic systems you have. And one of the invisible, say, benefits is that you get more direct payments. Money goes through the mobile phone, through the system directly on your account. You have the money now, not waiting for daily collection, monthly collection, whatever. For city authorities, basically, since most of the time parking operators are owned by the city authorities, we have increased revenue. There is no need for external power lines and stuff like that. There is loads of different benefits. Final numbers. We have done this complete project with our partners. You see the sign of the profit code, that is local company Split. In effectively 4 months of the field work. Usage more than 10,000 active mobile users in the first 3 months. It's 1,480 parking sensors on 45 different street parkings organized in 24 parking lot groups. And the benefits that we can see now in last 4 months, some parking lots get the utilization increased by 20%, and one of them that is not so far from the city center gets 40% increased utilization. 17% less parking violation. That is really good numbers to see. This is what equipment looks like. These are parking sensors, 2 different types we can discuss later. These are relay nodes. They can be omnidirectional and directional, and this is the gateway device. This is how it looks on the street. Just a small picture of a colleague with the drilling equipment. These are the screenshots from the mobile application. I can show it to you later what it really looks like. You can download it on the store, Android store and iOS. It's called Split Parking. So it's free to download and use. You can work with it, try to find parking. Gives you loads of information. These are few screenshots from the central systems. One thing I forgot to tell you, the sensor have dual technology. That's one of the reasons why we choose them. They have the magnetic and the infrared technology. So they have more than 98% detection rate. And this was the only the equipment manufacturer that allowed us to show you exactly every parking spot on the map to show if it's green or red. Others will say, okay, take the parking lot and we will just give you the numbers, because they were not so sure whether the results are correct or not.
Thank you very much.
Try to be very good.
Next company is Antico. Speaker is Carlo.
And of course, this can be easily connected to the next speakers.
I'm gonna piggyback on this last presentation.
Yes.
Maximum 8 or 9 minutes. Okay.
So, hi everybody, my name is Carlo Gasper and I'm a co-founder and CTO of the company, of the product and company Partio. What we actually do, we make a smart parking barrier that's used to secure a parking space. It is developed in Croatia and we just started mass producing and selling. But what I would like to talk about today is actually what my colleague was talking a minute before, is the problem with parking. So the biggest problem is that parking users and drivers are very, very frustrated because of the time they spend on finding the parking place. This increases the traffic, this increases the pollution and costs us money. And it's an ideal place for using IoT technologies to solve this problem. So most of the time we just drive around the town hoping God will find our parking place, but we know that's not the case. So we need to find a solution to get rid of that problem. And the solution is our parking barrier, because not only does it prevent physical usage of the parking place, but it can also be used to sell and reserve that parking place to other customers. So let's say you have a parking lot in front of your house, you can buy the barrier and you can put it in our system to try to get some revenue. Why not? You're at work from 8 to 5, why not sell your parking place and make some money? Extra money is gonna, everybody likes money, I mean. So if you look at the current trends in the world, in just Europe there's 440 million parking spaces that are not regulated in any kind. So the place for using IoT is huge, and it would be cool to not use the technologies that we have, to utilize it and make the experience better and make money out of it. So the biggest thing about the parking barrier is actually the competition. So there's a lot of parking barriers at the market currently that are direct competitors, but they don't offer the same stuff that our barrier uses. So, for example, you have a lot of barriers. You can see it all over, let's say, Split, and all over other countries where you operate them by using a key. So you got to get out of your car, you got to put the key and open it, put it down, get back in the car, and you're already wet from the rain or snow or whatever is happening around you. Then you have the barriers that are operated by a keychain, like a RFID tag, which is also good, but sometimes you're going to forget it. But one thing you're never going to forget, at least 90% of us, is your mobile phone. So why not connect to the barrier with your mobile phone, lower it down, you park, and you're done. And you just go up, and you're not wet, and you're not cold, and you're not frustrated. So, and the other part are the solutions of renting your parking spaces, but none of them in the world offer physical prevention of the parking. So when you let's say you're going to a city and you want to reserve your parking space, you're going to reserve it, but you don't know if it's waiting for you. You got your reservation there, but nobody is stopping anybody to park in that place. So this way, you know, when you buy, let's say I want to go to a meeting tomorrow, I buy the token, and I know at 11 o'clock in the morning tomorrow, my parking space is secured with the barrier, and I know when I come there, I'm going to connect to it, it's going to lower, I'm going to park, and I'm ready to, no hassle, no stress, no swearing or any kind of that stuff. So, as I said, our competitive advantage is actually the lower price, the technology that we use, using IoT modules and Bluetooth, as well as intellectual property because we got a patent for it. Our business model is going to basically be we're selling the products, we get the revenue from the hardware product, and as well as getting a piece of the renting. So let's say if you have, as I said, some people have 4 to 5 places in front of their house that are most of the time not used because you're at work, you're somewhere else. Why not rent it? You get money, let's say you get 20 euros a day, why not? Why not? If you can, if you're living in the center of a city, if you're living somewhere where it's busy and people need parking and don't want to pay for, let's say, parking at a garage or something, or it's just used, why not park at your place and get some money from it? So this is our team. We got Dario Boras, he's the CEO, I'm Carlo Gaspar, Marko Smonjal, Josip Plavrovic, and there's Stella the dog, which is the most important and most hard-working part of the company. So we just hit the market, and in the first month, we already sold 300 units. We got 500 pre-orders from customers in Croatia, in all of Europe, and wider. And as well, we got monthly capacity to make 1,000 units right now, and we're scaling and beginning to grow more. During our time, which is like, I think now seems like ages since we started, but it was at least 2 or 3 years now that we started making the smart barrier. We got a lot of acknowledgements, like we got the second best startup in the world 2017 in Singapore, where there were 5,000 startups. We got a few top 50 Croatian IT solutions and stuff like that, but this is all words. I would like all of you to come outside at the stand, and I'm gonna demonstrate the barrier for you, and we can talk about technology, we can talk what we did, how we made it, the problems we got into, and all stuff like that. So here's the contact. If you want to contact me, I'll be on the stand, and thank you very much for your time.
Next and last company is a very small and young company, SoftThings. SoftThings is similar to RadioSense. It's a startup and spin-off of the University of Salento. Piero is Piero Rametta, the speaker.
Good morning. Okay, Professor Padron already introduced our company, our startup that is called SoftThings, and the mission of SoftThings is the design and development of innovative solutions based on cloud IoT technologies in order to provide added value service both for other companies and for the end users in the several fields of application, such as healthcare, pharmaceutical, tourism, smart cities, and so on. In our mission, we exploit the experience gained through the participation to several research projects, international and national research projects done with the IDA laboratory. That is a research laboratory of the University of Salento, and most of us are a member of this research laboratory. I skip these slides and I go directly to some examples of services that we provide. Regarding CRM, customer relationship management, we develop innovative solution able to foresee end users' needs in order to increase the end user satisfaction and also to increase our customer company's profits. Two example services are NoQ and Barrow Beach. NoQ is a smart queue management system which aims to optimize the waiting time spent at restaurants before getting the table. With a smartphone application, the customer simply scan a QR code at the entrance of the restaurant and get added to the queue of the restaurant, and then is free to go for a ride in the nearby when the table is going to be released, the waiter with another smartphone application send a push notification to the customer so he can promptly come back and get the table. Baron Beach instead is a web application-based service for ordering drinks and food directly from the beach umbrella through a common barcode scanning application. So there is no need of customized application. The customer scan the QR code under the beach umbrella and get redirected to the digital menu of the beach, so you can directly put the order and get served directly under the beach umbrella. Regarding smart environments, instead, we are focused on the design development of innovative solutions able to monitor both objects or people in order to automatically send alerts to event of interest to interest users. Two examples of these services are Smart EC and Safe Rally. Smart EC is a service to improve the emergency management in hospitals. Able to automatically alert intensivists when an emergency cart is disconnected from the power supply. When an emergency cart is disconnected from the power supply, it means that the cart is going to be used for an emergency. So the intensivist must be timely adverted through a telephone call so they can go directly to the place where they are needed. Safe Rally instead is a rally driver's remote monitoring system for automatically alerting race officers in case of severe accidents. A wristband can detect when the driver loses consciousness due to an accident, so send an alert to the race officers to speed up the intervention. Finally, also in the context of smart environments, but with particular focus on Industry 4.0, we can design develop an innovative middleware able to allow the remote interaction with the industrial machines through several interfaces like REST APIs, push notifications, WebSocket, and so on, in order to optimize and automate some decisional process of during the production. Okay, this is a slide resuming the most important collaboration we are currently active. Okay, thank you.
Before we close the workshop, we have the last presentation, Peter Zonic, that will present some results related to his recent research focused on the solar tag.
Yeah, thank you very much. Thank you. A couple of years ago, in one presentation actually that vidjeti made, they developed some parking stuff, and one of the things that they had developed was detector for parking slot objects. And then I was wondering how they do that, and they said me that okay, there is you have to drill the floor, and then you have to put in some laser, and there are batteries, and there is a computations. And then I said, okay, how much does it cost? And they say like 100 euros or something. Okay, 100 euros for what? For detecting what? Detecting only one bit of information. I'm not sure if someone of you attended information theory courses, but I'm teaching this nowadays. And it's actually one bit of information. So is it occupied or not? So why to use 100 euros or even more? I heard that it's like even more for 250 or 350 euros per part. So it depends on parking configuration. And I said, okay, can we do something more simple, something more efficient, something more less expensive? So the idea was, okay, how can we do this one bit? How can we do that? And the thing is that we have recently developed something which is like completely different. So we have device which is working or not. So if it is working, then slot is free, and if it is off, then slot is occupied. So how to do that? So we're thinking of this solution. I have the prototype here with myself, and this is actually this solution. So we have the antenna, we have LoRa, we have RFID, which is actually battery assisted powered RFID, and we power the system with the solar cell. So when the car comes at the top of this parking sensor, it turns off because there is no power from the solar cell. Very simple, right? So the idea was how to use that. Is it possible to do that way? And actually we did it. And this first results we had is like, this is working. This is also working. But when you put it more underneath the car, then it stops working. And what has to be done, this is only the prototype, so I'm not wasting no more time. I'm just giving you to think of this future Internet of Things, how it should be done. In these very alternative ways. Why? What? Because it's not active, it's passive, it's solar powered, it has no batteries. It's very cheap. No, it's very cheap. It's order of magnitude cheaper than those that exist in the market. By just telling if it is on or off. So the first performance said that LoRa, when there is enough power, can power the whole parking if we were behind this building. So it's a kind of maybe 100 slots for one receiver, which you can cover. And the price is really, really good. Okay, that's much from me. If you have any questions. The thing is that the shadows that car is creating, which is not under the car, next to the car, is enough to be powered up. If you put it below the car, then it turns off. So we measured how much solar irradiance there should be to power this up. We did lots of experiments, we took these measurements, and we found out that this level of light which is below the car is just right. It's just right to turn it off. Thank you. Okay.
So, we can close the workshop. Thank you very much to all companies involved in this workshop for their very, very interesting presentation and contribution. Now, after this session, I can confirm my opinion that this kind of events it's very important for the IoT because we can understand, we can see the point of view of the companies that works today in the field. Furthermore, it's important, I think, to create, to do networking among all companies and between companies and other actors of the IoT scenario. Thank you.
Thank you very much. Coffee break will be served at 10:30. There is opening and you are all welcome for the
Presentations.
I think that yes.
Just one moment.
You know what?